Hi, welcome to Dissolve Chemistry. So in this video we will discuss regarding a very important topic, that is thermochemistry. Before going in detail with this particular, we will think of some general examples. See, for example, we come across with many processes. Say for example, early in the morning we go for breakfast. To prepare breakfast, again we have to lit the burner, gas stove, so where we are going to burn the fuel, so and we will get heat energy. So there we are doing combustion reaction. Similarly, if you prepare a duff, so we are going to add water and we will mix, so there is a evaluation of heat we are going to observe. Suppose you are preparing a juice, so there you will add sugar or salt to the water. Upon dissolution, there is an exchange of energy we are going to observe. So like many phenomenons which we see in and around us, all are associated with change in energy. Similarly, when we do any chemical reaction, during which what happens, there will be an exchange of energy will takes place. Means either energy is absorbed from the surrounding by the reaction, or during the reaction energy is required to be provided to that to bring that particular reaction. As I said, a combustion reaction if you take. So there what we will do, when you burn the fuel, you will get tremendous amount of energy in the form of heat. Okay. Similarly, say for example, I am dissolving a ammonium chloride. Okay. So there what happens, it is going to absorb the energy from the water, and water gets cooled upon dissolution of that particular compound. So likewise, during any chemical reaction, either it will absorb the energy from the outside to bring that particular reaction, or during that reaction what happens, there is a lot of energy is being liberated in the form of heat. And this exchange of energy is the subject of your thermochemistry. So then how we will define that? Okay. The study of transfer of energy in the form of heat during chemical reaction is called thermochemistry. Then is it the branch of thermodynamics or not? Yes, it is a branch of thermodynamics, because if you consider, if you are carrying out a reaction, you will be carrying it in certain vessel, maybe your round bottom flask, or maybe test tube, or maybe beaker. Okay, so all these are going to be like a system, and the constituent of that will be the part of the system. So therefore, during which what happens, suppose if it is giving heat out means, or it is absorbing heat during the reaction means, it is exchanging heat with the surrounding. Of course, it is acting as a system. Okay, and it is exchanging heat during the process. So therefore, we can call thermochemistry as a branch of thermodynamics. Okay, so we will go in detail with this. Okay, first we will talk about, see, this exchange of energy will occur in two ways or in two different conditions we will take. At constant volume and at constant pressure. Now, if you carry out a reaction keeping the volume constant, then what happens? The energy exchange, whatever it takes place, or absorption of the heat or evolving of the heat, that all lead to the change in the internal energy of the system, because it is not doing any work. So therefore, whatever the change is, if there is an absorption of energy, say for example, okay, suppose you are carrying out reaction in a sealed vessel or sealed tube, so then whatever the energy is absorbed, that is all being converted into internal energy of the system. Now suppose if the energy is given out during the process, meaning is what? There will be a decrease in energy, internal energy of the system. So therefore we call it as once again change in internal energy. So that we represent as QV. Similarly, so when the most of the reactions, most of the processes, transitions, whatever we bring, so all that we are going to bring at constant pressure or in open vessel. Open vessel means carrying out at a constant pressure we call. So in that case, the exchange of energy leads to what? Change in not only internal energy, along with there will be an expansion, particularly if the gaseous reactants and all, if they are present. So there is an expansion work is being done by the gas. So therefore, that change in energy, we call it as what? Change in enthalpy, which is equal to QP. The absorption or evolving of energy in the form of heat at constant pressure, we call it as what? Change in enthalpy of the system. Okay. So now, as I said, most of the reactions are carried out at constant pressure. So therefore, we will talk about enthalpies of the reactions, particularly when the reactions are going to involve solids and liquids. So then change in enthalpy, change in internal energy, both will be same because volume change is negligible even if you carry out in open vessel. So therefore, we cannot differentiate between these two. And now we cannot check the work done by the gas QP, or we can write it as delta U plus delta PV we will write. So therefore, change in volume always we cannot measure. So in such circumstances, what we will do is we will take the whatever the work done by the gas in terms of what? Number of moles of gaseous reactants and gaseous product. So therefore, delta NGRT, because we know that PV is equal to RT. So therefore, we will take like this. So change in enthalpy we can give by using this equation, where this delta Ng represents number of moles of gaseous products minus number of moles of gaseous reactants. Okay. So by that we can calculate, and we know that R is going to represent 1 mole of gas, how much amount of work it does at means per Kelvin temperature. Okay. So therefore, and the temperature at which we are carrying out, that is also there. So that is how we can give this enthalpy, okay, for a given reaction or process. Now all this we will study as enthalpy of the reaction. So we will call enthalpy of reaction. Okay. And it is represented by delta H, or you can say reaction. Okay. Enthalpy of reaction. So now how to define this term enthalpy of reaction? See here, I told you that the thing what happens during the reaction, either the energy is absorbed in the form of heat during that reaction, or the amount of energy is given out in the form of heat during the reaction. The amount of energy absorbed or evolved when 1 mole of reactant converts completely into product. Completely into products, then it is called enthalpy of reaction. Okay. Is it clear? The amount of energy absorbed or evolved when 1 mole of reactants converts completely into products, then it is called as enthalpy of reaction. Energy absorbed or evolved, we are using term. So when the energy is absorbed and when the energy is given out, so based on energy absorption and evolving, we are categorizing them into 2 types of reactions or processes. That is, one is called exothermic process, okay, and another one is called as endothermic process. See, for example, okay, during the reaction, if the heat is given out, okay, or heat is evolved, so when it will evolve, see, so if you consider, okay, So this is, we take it as reaction coordinate, and energy if we take, if the reactants are having, say for example, this energy, R is going to give the products. Okay, so we will take it little higher. Okay, here we will take R. Okay, during this conversion, okay, so your products are having lower energy, and this difference in energy between reactants, when you see the energy of the reactant and products are having lower energy and your reactants are having higher energy, and this difference in energy, that is going to come out as what? Heat. In the form of heat it is being evolved. So therefore, okay, so delta H is equal to, how we write? It is summation of enthalpies of all the reactants. First we will take products minus summation of enthalpies of the reactants. Sum of the energies of all the reactants, we call sum of energies of all the products. So when you take the difference between these two, then we call it as what? Change in enthalpy. Now when you look into this, what you will see, that energy of the product is less than energy of the reactant. Overall products, if you consider, their energy is very low than compared to your reactants. So therefore when this term is smaller than this, so then your overall value will be what? Negative, when enthalpy of the products is less than enthalpies of the reactants. So then your delta H is represented by negative sign. So therefore during exothermic process, heat is given out by the process. Exo means out. The energy is given out in the form of heat to the surrounding, and that is represented by the sign negative. Okay. Similarly, we will talk about endothermic process. Endothermic process. Say for example, we take, so now for this also we will draw an energy reaction and energy coordinate we will take. So energetic of this reaction we will see. So the reactants are having, say for example, this energy, and your product is somewhere here, its energy. So therefore this gap, what we call a difference in energy between reactants and products. Now you see the energy of the product or enthalpy of the product is greater than enthalpy of the reactant. So therefore when you substitute in change in enthalpy, sum of enthalpies of the products minus sum of enthalpies of the reactants, then what you will be getting? You will be getting positive value, delta H is equal to. So therefore, so during the process, if the heat is or energy is absorbed in the form of heat, so then those processes are said to be, or reactions are said to be endothermic reactions, and delta H for such reactions are represented by the positive sign. Okay, the values, if they are given in positive sign, it is implied that the process is said to be endothermic. Okay. So now we will talk about standard enthalpy of reaction means what? Standard enthalpy of reaction. See, standard meaning is what, and it is represented like this, delta H naught R. Okay. So standard enthalpy of reaction. Okay. So why this term standard we are going to use? If the enthalpy of the reaction is determined under standard conditions of temperature and pressure, so then those enthalpies were said to be standard enthalpies. Okay. So what are the conditions? You have to maintain the standard temperature. Standard temperature. Usually the standard temperature we will take by convention as 25 degrees Celsius. or 298 Kelvin. Okay. If it is not mentioned, because some of the elements or compounds or substance are having their standard states at different temperatures. Say for example, take standard enthalpy of fusion of ice. If you take, it has to be taken at 273 Kelvin. Similarly, the standard state of iron is found to be iron solid in the pure state at 500 Kelvin. So if specifically if it is not mentioned a particular temperature, then it is always understood that it should be 298 Kelvin temperature, and your pressure should be standard pressure. We will take it as what? Standard pressure is taken as 1 bar. Okay. And apart from this, the third important point is that the elements or substance, whatever you take, of which you are going to determine the enthalpies, so those should be present in their standard state. Say for example, we will take now the standard state of water at this 25 degrees Celsius is H2O liquid water. Okay. Similarly, the standard state of hydrogen, nitrogen, oxygen, okay, at this temperature will be gaseous state is their standard state. Okay, gaseous state is the standard state. For example, you can take iron. So its standard state is taken as iron solid at 500 Kelvin. Okay, we are specifically mentioning the temperature. We should make note of that. Similarly, you can take, say for example, carbon is taken as standard form is graphite. Okay, if it is mentioned as a carbon graphite, and if you are checking its combustion or whatever it is, then we call it as what? Standard enthalpy of reaction we call. Okay, then graphite, sulfur, we will take rhombic sulfur, okay, as a standard state, right? So like this, the element or compound, if it is present in the most stable state under these conditions, and that preferred, or it is said to be standard state of the substance we call. Okay, so if we have all these criteria satisfied, so then the whatever the change in enthalpy occurs under these conditions, that enthalpy change we call it as what? Standard enthalpy of the reaction, particularly for 1 mole of a substance which is going to form or which is going to be reacting or whatever it is. Okay, so we will talk about that enthalpy, standard enthalpy we will define now. The change in enthalpy when 1 mole of product is formed in its standard state by the combination of reactants in their standard states under standard conditions of temperature and pressure. Under standard condition, or we call it standard conditions of temperature and pressure, means okay, 298 Kelvin temperature, such as 298 Kelvin temperature and 1 bar pressure, okay, is called as standard enthalpy of a reaction. Okay, so we will take one example. Carbon graphite, because it is considered to be a most stable state in room temperature. So O2 gas to give CO2 gas, 1 mole of the product we will get, right? So then change in enthalpy, H naught of the reaction is equal to minus 277.7 kilojoules per mole. Okay. Now suppose if we take, instead of carbon graphite, if we write carbon diamond, if you take, and if you go for combusting yeast, and whatever the enthalpy you get, we cannot call it as what? Standard enthalpy of the reaction, because it is one of the condition that you have to take the reactants and their products form should be in a standard state under given conditions. Okay, then only we call it as what? Standard enthalpy of the reaction. Now let us define the next term called thermochemical equation. Means what? Thermochemical equation. You might be knowing that we are going to write a balanced chemical equation. Okay, for any reaction, if you take maybe organic, inorganic, whatever it is, generally we will write a balanced chemical equation. So this, what do you mean by, again, thermochemical equation means what? Right? So here, if you are writing a balanced chemical equation along with the physical state of the reactants and the products mentioning along with that, and apart from that, if you are mentioning the change in enthalpy of the reaction, okay, or whatever the exchange of energy taking place during that reaction, if you are that also, if you are mentioning with the reaction, then that particular equation is called as thermochemical equation. How we define this? A balanced chemical equation where the physical state of the reactants and products were mentioned along with change in enthalpy of the reaction, then that we call it as what? Thermochemical equation. See here. Here we have written carbon graphite solid and dioxygen gas, and it is going to give carbon dioxide gas. Along with that, what we have mentioned here? Change in enthalpy during that reaction. If you mention along with this, then it is said to be thermochemical equation. Okay. So I hope you have understood what do you mean by thermochemical equation. Okay, we will stop here, and we hope in the next video we will discuss regarding enthalpy change during phase transitions and enthalpy of formation. All that we will discuss in the next video. So please subscribe our channel to view more videos. Thank you for watching. Thank you.